Jeff Mason's our sponsor, client, depending on how you look at him. He's the one who's at the Charter Cities Institute and is the one who actually knows what's going on.
Oh, awesome. So I have a couple more members that do want to be a part of the project, but were not able to come today. But you are recording this, so they'll be able to watch this.
Excellent. Yeah, I need to figure. I don't think I've actually published any Zoom meetings yet, so I don't know how that works, but we'll figure that out and get them involved. I suspect there'll be a lot of impromptu meetings to try to get folks started on various things. I went through quite a lot of this today. I don't know if Jeffrey, if you saw my my post or my email about the initial results. We do have some initial results from some early analysis. So we'll be talking about how that works and kind of what's going on. And actually, I think we'll probably give another minute or two, see who else comes in. I'm going to put up a wiki page. Let me go find that here. You can all follow along with. It is this one, which I'll go stick in the chat. If I can figure out how to do it. Where'd the chat go? It's under participants. No. Chat moves around when you. Oh, there it is. When you share. Okay, here we go. So this is the wiki page. I think this should be visible to everyone, regardless of whether you have an account on the system. And I'll put a couple links in there about the meeting. In fact, let me go edit this right now. So these are two notebooks that we'll go through. We'll talk about I'm gonna let Jeff talk about the project and kind of what the reasons are, how the Charter Cities Institute works, and then Taylor, if you want to kind of introduce your team to the folks that aren't on your team and talk a little bit about that and what you hope to accomplish, and then we'll kind of go through what data is available and what we're going to get started on, and a little bit about how to use the project management site to get things done, since that's how we'll be coordinating. So Jeff, do you want to start? Let me unshare. There we go. All right. Oh, I can't hear you. Oh, audio troubles.
How about now?
There we go. Excellent.
Okay. Sorry, my headset was partially unplugged. Yeah, so as Eric said, my name is Jeff Mason. I'm a researcher at the Charter Cities Institute. So we are a think tank in Washington, D.C. And as the name implies, we work on doing research on and advocating for charter cities as a solution to global poverty. The quick and short version of what a charter city is that it is a newly developed city with basically a blank slate in sort of the governing framework and the regulatory and administrative framework. The idea being that you can sort of make meaningful reforms to governance and institutions more rapidly than you can in existing political environments, and in areas where they're not seeing economic growth, but they are seeing high levels of urbanization. This can be a tool to promote growth and promote reform, and also accommodate some of the rapidly growing urban population in much of the developing world. So what we do is a mix of activities. We do research projects like this on, in some cases, things that are either directly on charter cities or on related topics. So in this case, the related topic being special economic zones. Um, and then we also do sort of, I guess, what you might call technical assistance. So in some cases, we work with actual new city developments, of which there are um, a number of all around the world, of targeting all kinds of different types of development and size, and it's quite an interesting mix of what people are actually sort of building out there. So that's one side, and then we also work with governments that are interested either in doing sort of um, general charter cities legislation, or sort of specific, like a specific case, like a concession type agreement for a charter city-esque uh, project. So that's a quick overview of what we do, what our organization is about. Um, and so with this specific project, we recently, the reason for this project, there's recently like a, maybe you could call it like an impact evaluation, from an organization that kind of takes cause areas, and sort of does write-ups on them on behalf of potential like major donors, um, or organizations that are trying to figure out where they should direct their own time and energy or their resources. Um, and so one was done on charter cities, and a key piece of that report, um, because there, any sort of charter city or charter city-esque projects in existence right now are fairly nascent. So there's not a whole lot of data to go off of just yet. So special economic zones are sort of a proxy for that, and to try to come up with sort of a baseline um, estimate and expectation of what a charter city could accomplish. Um, this report used a review first done by the World Bank in 2017, of various estimates of the effects of special economic zones. And I think this was reformed into a sort of more compact journal article version that they published 2 years ago. But the short end of the analysis and is essentially that, generally speaking, um, or maybe on average, SEZs don't perform uh, all that well. There are sort of notable um, cases of countries who have regimes that are quite effective, or there are certain sort of institutional or contextual factors in which um, SEZs do perform particularly well. But by and large, um, most countries, in the ways that they have tried to do them, haven't seen great success. Um, and so what we wanted to do is we wanted to do two things with this. One, try to do a sort of more up-to-date meta-analysis of the existing literature on SEZs, bringing in some work that's been published since, but also in terms of how we write it up for our own purposes, sort of better contextualizing, in our view, how charter cities relate to this literature. And then the second piece, which is what Eric has been chatting with you all about, is also doing an updated um, original study using nightlight data, which in the past maybe 15 or so years has kind of come into the economics profession as sort of a proxy tool for measuring economic activity, and combining that with data sets on SEZs to produce some updated estimates of the growth effects that SEZs are actually seeing. Yeah, Eric, do you think I missed anything there?
No, I think that that pretty much gives us a good basis for it. I want to apologize. I live with a bagpiper, so if you hear bagpiping, that's
I can't hear it, so
yeah.
I
It's
don't know if it was
well,
on
you're
mute.
lucky because it's so loud. He's
So I'm
practicing
just
now.
curious. So when we're looking at this data, I mean, are we going to be looking at sort of like the outliers? Like maybe we're looking at SEZs that have done really well, or maybe the ones that are doing really poorly. You said that in general they don't do that great. But like if we were going to sort of direct our analysis, are we going to be trying to figure out any sort of like what policies have been maybe caused either for SEC zones to do poorly or to do better? Or are we just sort of getting like I've just been kind of wondering what the
Sure,
question behind what we'll be doing is.
sure. So I think part of it can, and this part I think is sort of relatively simple because it's just sort of take your model, take like the generalized model and like apply it to a data set. What the effect is of growth, potentially taking data sets that are a bit more rich than what some of the existing stuff has done, but then
Okay.
getting at what you kind of talked about there, hopefully trying to do a better job than some of these past analyses have done, of trying to
Okay.
figure out sort of what the actual sort of contextual factors or policy tools um, that do generate sort of success or failure. And there are some that are relatively well established in the literature, as being um, good or bad for success. It's like one example being, it's pretty well known that like if you build an SEZ in the middle of nowhere, it's going to perform really poorly compared to one that is sort of in the proximity of a major city. Just
Right,
as
that
one
makes sense.
example.
Yeah.
So trying to drill down, um, hopefully into some of the factors that are sort of a little bit more of an open question, or where there are conflicting results in the
So
literature.
maybe what we're looking for is like distinctive features that attribute to something that is poorly, or really like increasing GDP SEZs, and then we can figure out what those factors are. Maybe not so much just policies. Um,
Yeah,
is that what you're looking for? Um,
yeah, I think so.
Yeah,
okay.
so we have several fairly rich data sets, and we'll go over those a bit today. The those data sets give us both links to the proxy for economic growth, which is nighttime lights, and the UNCTAD data set, which is a United Nations group that went through and produced a fairly rich data set, maybe 80 columns of various aspects of SEZs that maybe about 10%, I think, of the total known SEZs. So
Hmm.
it's not a big coverage, but it's very rich, and it gives us a way of linking a wide variety of features to the proxies for growth. Um, and so that's going to be the main emphasis for this project. We will try to incorporate other things. So there's a lot of things that are important for an SEs for any economic growth: roads, proximity to airports, other policies in the education level of the local population. There's lots of stuff,
Hmm.
and there's quite a lot of that that's already in the data sets we've got. There's quite a lot that we can link in from elsewhere, and so a lot of what we'll be focusing on is how do you do the basic analysis with the data sets that everyone else has been working with, so we can get a handle on how that works.
Hmm.
And then how do we expand on that to look for other options? So once we've got folks who are basically comfortable with manipulating the data that exists, then you'll be able to run your own hypotheses. That's really where we want to get to, is that analysts working on the project can do their own hypotheses on what's the importance of road networks, what's the importance of education, what's the importance of other factors in the growth rates. And so we've got a really good handle, or really good data sets for basing on that. And then eventually what we need to get to, we're going to spend some time exploring stuff just to get collective feeling of how all this data works. Hopefully reading a few of the papers. There's a lot of research on this.
Yeah.
And you'll find that they're mostly using the same data sets. That's one of the things that a lot of folks don't understand about most of this research, is that it turns out in most fields, there's relatively few data sets they work on, and the things they're doing on them are not really sophisticated. There are lots of researchers that are incredibly sophisticated, but 50% of what's out there, very basic analysis on widely available data sets. And so you can do that too. And that's what we're going to try to get to, and then expand on that to try to answer some of the questions.
So, with all of the research paper sets in the library, I was wondering how did you want to maybe prioritize how we get through all of that, and if maybe there would be a way that we could break it up in a smart way to say someone was just focusing on a specific area or types of policies or certain methods, and then it was broken up in that way that then people could kind of have their niche in the research, and then
Yeah.
you have a better way of comparing across the research papers that you do read, instead of just everybody getting a random paper and breaking it all apart. And I don't think there's any way that any one person could get through it by themselves. Um, it's a lot. So I don't know. What were your thoughts on how we go about kind of tackling all the research papers that are there?
Well, Jeff, that's your space.
Sure. So there's a lot of different ways that could be potentially broken up, right? Because some of the papers are sort of either looking at specific countries. There's a few in there that are actually just looking at specific zones, whereas others are sort of looking much more general. Some are looking at certain types of effects versus others. So there's a number of potential ways that they sort of could be broken up. I think a sort of relatively uh, a first step for helping make that a little more sensible will probably just be to sort of go in and tag high level tags on what each of the papers are, to help sort of introduce a little bit of structure
Yeah.
to the master list.
Yeah, I was thinking, you could probably just go through each of the abstracts and sort of just pull out and say, okay, we can categorize this
Yeah.
group into like this country and this into that. I started to do that. I started to make like just a spreadsheet where I put the article in and I started breaking it down, and I was reading the abstracts and trying to find like a nice tidy way of being able to break them all apart. And I'm not super familiar with Zotero. I don't know if there's a way to be able to do that where you can, if there's a way to be able to break it apart in there, or if you just make folders or something.
We do have folders. I need to see if you have privileges to do that, but you can. There is one folder in there already, the Modus Nighttime Lights, which I created for some of the nighttime lights research. But there's few options. One of them is tags, and the other is folders. And the folders are nice because if you put something in a lower level folder, it shows up in the higher level too, I think. So Jeff and his interns have put in a huge number of papers. I mean,
did it grow? I felt like every time I went back and looked, it was bigger. I was like,
no. Has it been you, Jeff, or is it Max has been busy lately too? He's been real busy.
I haven't added anything in lately.
Yeah, this is a fantastic group. So I've been meaning to go back through. I haven't done a very good survey of the literature yet because I've been focusing on data. But and partly what my plan is to get people familiar with what's available in the data, because you kind of have to know the data and then you have to know the research. Mm-hmm. And so the research part of it, we do need to go through, and this is probably something where we can talk to the CCI folks and kind of do a collaborative thing where once we've got a handle on what's in the data and kind of how it can work, what we really should be looking at, because those two things work. They work in a kind of a cycle. You can go read all the research, but then there's 3/4 of that research you can't use because that's not what's in your data. And so if you understand the data, then you can focus on the research better, and vice versa. I don't think we have. I've done enough of a survey of the literature to feel relatively comfortable we're starting in the right spot. But there's always more to learn.
Yeah,
But
I mean, it's such
usually
a
think of it as a
broad
spiral.
subject too. There's so much to it. It's so
Yeah.
complex. I feel like you could probably just go on and on. I mean,
Yeah. Well, let me go through a little bit of what we've got now, so that people know how to get started on that. And I'll show you I wanted to kick off what the project structure looks like, what tools we're using, how to get engaged with that, where we're going to issue tickets and issues that you can connect with and try to do some work on, and just what to look at, because there's an awful lot here. And it turns out that the analysis it's fairly sophisticated. This is actually, for data analysis, one of the more technically complicated projects I've worked on. So we might take a little bit to get people's technical skills up to speed, because they are kind of weird. Is there anything else, Jeff, that you want to go through before we jump into that?
I don't think so.
I was kind of curious, like I've been like taking a lot of Coursera classes this summer, trying to like just build up my technical skills. Is there something specific that maybe I could be working on for this project? Um, Uh, I saw some for different geospatial mapping courses I could have taken, but I wasn't exactly sure what exactly, what packages we would be using. Um,
Yeah, we'll go
that
through that today. You'll get kind of an overview, and I can work with you more if you want to have a private meeting after this. We can go through in more detail what those are, but I'll have a couple suggestions after today. It's mostly it's a whole lot of Python, and there's a fair bit of raster work in NumPy. And then after that, it's statistical stuff. So I'll kind of walk through what that process looks like. And again, other folks will have other ideas. I'm absolutely thrilled to have you do something different. I took a first stab at things, and that's not definitive. So go ahead and apply your better judgment where it's reasonable. But if you are looking for help or guidance, then we'll be able to, you can follow along with the stuff that I've already done.
Okay, great.
So the first thing to note is that, let me go share my screen. And let's see, here it goes. So we're going to be using Redmine as our project management site. Redmine is awesome. I've used all sorts of commercial tools, and I always keep coming back to Redmine. The project, so this is the main Redmine site, redmine.civicknowledge.com. The projects up here for projects. You're looking for SEZ analysis, and these will be, there's a wide variety of links I've sent out, but this is the main project site. Occasionally I put up other project sites for other websites for displaying results of things, but this is going to be the main one. And on this, you can get to this, and I will post. Let me post that in the chat just in case somebody doesn't have it yet. If you want to get into this, then the way to do that is on the data libraries, how to join a project page, which is also in the chat. Mostly you're going to want to join the meetup group. Clearly, all of you got here through meetup, so that's good. You don't need to have a GitHub account, but it's not a bad idea. There's you can get along without it, but there's a lot of stuff that goes through GitHub. I much prefer to have that as the storage for everything important, because one of which is that we use a lot of Jupyter notebooks, and it renders notebooks, so it makes it a whole lot easier just to show people notebooks. I was hoping to get some Google Colab stuff going, and I'll probably do that for the next time in case anybody wants to try out Google Colab. That's a great way to do your Google Notebooks or to do Jupyter Notebooks. And then the important part is this one right here. Register account on Redmine. And I see a few people already doing that. So great. If you click on this, you'll get to the account registration page, and then I will, within a day or so, create an account for you. And if you click the thing that says, I'm interested in the SEZ project as part of the questions for the registration, you'll get added to that project. So here's what that project looks like. Here's all the folks that are involved in it. The main things that are important about this will be eventually the issues. So we don't have a lot of issues here right now. I've got a couple bugs and ideas, but this is where we'll be creating challenges. Requests for analysts to go do some sort of analysis. Can you look at the relationship between this variable and that variable? This isn't quite what issue sites are meant for. My hope is that people can go tackle these between meetings. Usually you assign an issue to a single person or maybe a group. So we'll see how that works, but you'll get the ideas on what we're trying to look for here. Now, a lot of the way I run these projects, the data libraries projects are half for the nonprofits who are doing something important in the world, like the Charters Cities Institute, and they're half for you all who are learning things, you're contributing things, you want to know something, you often have your own goals about what you'd like to try out. So we're fairly flexible on what it is you're doing. If you want to try something slightly different, you're interested in trying out some technique, go for it. The challenges that are going to go in this issues area are recommendations, but they're not requirements. The other two sections that are really important are going to be the wiki, which is where we put any information that needs to be shared and communicated. You'll see that we've got one for the kickoff meeting, and I'm going to post this one to the chat as well, because this has the two links to the data sets that we're going to be talking about today to kind of get a handle on how the data works. But there's other stuff in here. The main ones being there's a whole lot of information on the various data sets that are available. These useful data sets are the sources for the main data sets we're going to be using. The first one is the SEZ database that has about 10% of all known SEZs and great detail on them. The second one is this absolutely awesome data. This is like a gold mine. If you're a data person, like, oh my God, I can't believe this exists. The nighttime lights data is, if you go to the original sources, which is NOAA, National, I don't know, what does NOAA stand for? Aeronautic Atmospheric Administration. And I think NASA has some of them too. They've done a fantastic job of flying satellites and taking pictures for decades. They've not such a fantastic job of making those things easily available. These researchers at, I think, University of Idaho, took all like 28 years of these satellite images, and they harmonized them, put them in the same format, stuck them on a website, gave them the same ranges, made them all compatible, and then let you download them. And this was just absolutely goldmine. So we're going to be using that. One of the things we should do, however, is try to calibrate it to understand what does it really mean. So these data sets, which I'll show what they look like. Let's do a share. Let's see.
Real quick, Eric, while you're bringing that up,
Go ahead.
was there anything else that you think you need from me?
Oh yes, it's late.
Yeah. I'm on the East Coast.
Yeah, he's late.
Oh wow.
So go ahead and ask him anything else you got.
I'll put my email in the chat.
Yeah, sorry about that.
No. You're all good. Yeah, let me know if anyone has any questions either about this or anything else our organization is doing, or whatever. Feel free to reach out. And thank you for your interest in our project.
Fabulous. Thank you for joining
Excited.
us.
All right, thanks.
Have a good night.
Thanks, you too. Eric, let's follow up.
Yeah, just shoot me a meeting time and let's get back together.
Okay. All right. Have a good night, everyone. Bye bye.
All right. Good night.
Night.
All right. So here's what these nighttime lights look like. This is a big GeoTIFF, which means it's a geographically referenced image file. And it's referenced to latitude and longitude. The average size of each pixel is something like, I don't know, 100 square kilometers, 10 kilometers by 10. They're big. They're real big. And yeah, you get a nice view of the world. This runs from 1992 to 2018, and it's the whole planet. It's absolutely astounding, what you can find in this stuff. I was cruising around Texas, and man, you get the fracking in Texas. It's crazy what that looks like over the years. It just like the whole Hall of East Texas just explodes into light a few
It
years
would
ago.
be. Can you watch it like as a animation over the years?
You could if you were
Just like-
to assemble them. It's actually not hard, but it does take a little bit of programming. You can put them all together.
Yeah, that would be cool to see.
You do need to get in fairly low level to kind of see stuff at a reasonable frequency.
Oh,
I mean,
wow.
Europe is kind of way out there, but where we're going to be focusing is largely in China and Africa, and China, Vietnam, Indonesia are the places that have some of the most growth. South Korea is a big one. I don't remember where South Korea is, running somewhere. But we'll be going through that later. Now, most of what we're going to do with these is work with them using Python and the raster.io library. Right now, you're looking at it in QGIS, which I highly recommend as a tool for doing basic geographic visualization. It's really easy to get stuff in there. I mean, I literally just fired this up and dragged the TIFF in here, and it popped up just fine. Now, these are 8-bit files. So the light intensity goes from 0 to 255. And what is those numbers mean? Who knows? Who knows? Like I don't know how they scaled them, and it may be somewhere in their documentation or their papers, but I don't know. So we're going to have to calibrate these if we want to understand what does light intensity mean in terms of economic activity. We can say more or less. We can't say dollars, right?
Mm-hmm.
So let me go back to
Where's Vegas?
What's that?
Where's Vegas?
Oh, Vegas. Yeah, Vegas is probably just all it's over here somewhere.
I was looking for it. It didn't look as bright as
well,
expect.
it's some of these cities in Asia, they're or even like Mexico City, they're just amazingly bright. Vegas is fairly small. The Strip is actually pretty small.
Yeah.
Relative to everything else. I mean, it's going to be right over here. That's probably it right there.
Oh yeah.
Okay, so let's take a look at. So that's one of the data sets we're going to be working with, and so back to the project site. This is our wiki, and we are looking at the. We're going in the wiki, going to data sets. Though the other one is this UNCTAD SEZ data set. This is a really fantastic, it is a geographic data set. It does have latitude and longitude in it for each of about 500 some special economic zones. Now, special economic zone is not what the Charter Cities Institute does. A special economic zone is, a charter city is a whole city that has its own laws and rules about business development. A special economic zone is kind of like a business park with its own rules. It literally is about business park size. But if you go into that data set, if you click in through there, what you'll get to is you go into this visualization tab and you get this SEZ viewer. This is really worth looking at because it's a really excellent application. It looks custom too. Come on, let's get in there. They might have built it on a platform, but I don't. Well, actually, I did find the platform they built it on. It's a really good one. But they pulled in just a crazy amount of data, like building footprints. A lot of these building footprints can come out of OpenStreetMap. They're made by volunteers. But I think they might have gotten these from some other source. There is just a ridiculous amount of data in here. And so they list all of the SEZs in the main SEZ data set. And then they provide this really cool viewer that gives you a lot of different options, including, you'll see over here, here's the nighttime lights. Everybody uses nighttime lights. So we're not breaking any ground with this, but we are going to build a basis for applying other stuff to it. So it's still worth doing. As you can see, these are not cities, right? They're actually pretty small. Any questions so far?
Not yet.
Okay, let me go back to where was I? Okay, there's our data set. Okay, so now those are the main data sets. Now, a lot of what the library does is process and collect data sets to make it easier for analysts to get to. And we put those on our data repository, which is under the process data sets. So this will take you into the main San Diego Regional Data Library application, which is just WordPress. And these are the 3 data sets that we're going to be doing most of our work with. And I'll show you how these get used in a Jupyter Notebook in a minute. Some of these just have links to the URLs. So in this case, this package has a collection of URLs. Each one of these URLs is one of the raster zip files, which I spelled worldwide wrong. For getting these various packages. Now, if you click on these URLs, you'll get something, but they're meant for using inside of a different data package. So I'll show you how to do that in a minute. We've also got a collection of administrative boundaries that I tracked down. These are the maybe 9 countries that have the most SEZs in them. And so there's a couple ways of looking at what the growth of an SEZ is and what its economic output is. One of them is to look at the light intensity in a buffer region around the SEZ. Just select a circle around the SEZ that's 10 or 20 kilometers wide and just count how many pixels or what it values. The other way is to look at the boundaries of the administrative divisions, because that's often where economic activity gets constrained to. Not always. I mean, it doesn't always happen in the United States either, but that would be another way to do it. Also, because the second level administrative divisions, which in the United States would be counties, in other places they call them counties or precincts or provinces or something. They may have different rules or regulations that make it sensible to look at what's going on in the boundaries of them. So I've collected those here as well. And then the other thing that you might want to pay attention to at this site is the news. You should be getting emails from my news postings. When something important happens, I'll stick it up here and then everybody on the project will get it. The other thing that's worth noting is the research. So this research will take us into Zotero. If you do anything with research papers, there's a few tools that are really good for managing your bibliographies. Zotero is a very excellent open source one. It's free. The other one's Mendeley. The problem with Mendeley is that it's literally owned by Elsevier. Elsevier, I forgot how to pronounce it. And so for you and I, if we're not involved with a university, getting the research paper involves going to Sci-Hub. And I'm not so confident that Elsevier is really happy with you taking papers from Sci-Hub that you didn't pay Elsevier for and then putting them back into Elsevier system. So that's why we have Zotero. If you don't know about Sci-Hub, go look up Sci-Hub. It is an absolutely awesome way to get the actual paper and not have to pay $30 a piece. It's not exactly entirely legal, but it is completely and absolutely moral. So, and the woman who's doing it is there's a campaign going to get her a Nobel Prize because the value of being able to get to these people, to get to these papers is really good. Archive is if it's on Archive, if you're doing a preprint, that's fantastic. But a lot of the papers didn't go out to Archive preprints. No, it's Sci-Hub. It's right here. You go and look for, well, this link right here. Actually, what you do is you go type in, where is Sci-Hub now? And you'll find a couple sites that'll find it to you because will link it to you because Sci-Hub moves around because it's not 100% legal. So when you find it, it'll link you back to a lot of these papers. The other way you get a paper is you write to the author and just say, can I have your paper? And they will often send them to you. Anyway, if you go into the research section on the wiki, you get to our Zotero library. And you'll get a huge array of research papers. It's actually gotten to be too much. We had some of the highest impact ones early on, but Max, the intern, has been really busy putting more stuff in. And so it's a bit much. But a lot of these will get you a sense of what the scope of the analysis is. If you go into the MODIS nighttime lights, these are ones that, in fact, the first paper right here, the Harmonized Global Nighttime Data Set, that's the one that is the paper about the data set we're using. The rest of these describe the other analyses of using that. So this is worthwhile to use, but you will have to go through Sci-Hub to get some of these research papers.
I'm thinking that maybe after taking like a look at the data sets that you just showed us, that maybe one of the ways that we could break up the research papers would be sort of based on those data sets. So like those regions that you were just showing us in that data set, the the second level, what was it called?
Second level administrative districts?
Yeah, those districts. Like maybe we could break up the research papers based on those districts.
That
I
might
don't know,
work.
just a
That is
thought.
one of the, you'll notice that the intern's been busy. He's been very busy. Oh my goodness. Support vector machines. He's really busy. I don't know that all these tags come from our crew. They might get pulled out of a tag database that is applied by the people that write the research paper. But you may be able to do searching on the tags to look for some of these regions. So I'm pretty sure that well, let's see what we get. Yeah, so Vietnam should be in here too. Not so much. Korea? Yeah.
So
Well,
that's searching the tags. It's not searching like the actual articles themselves.
no, we don't. So it's I think it's hard to, some of these have attachments in them, and I don't know that you can actually get them with your permissions. I might need to go through that. Let me see what happens if I log in. Yeah, I need to get you a higher level of permission. Let me see if this gets to me. Yeah, this is one that we stuck in there. So I'll have to, for those of you that want to actually read the papers, let me know and I'll bump you up on permissions. You may be able to log in and get them anyway, but we can work that out. We just don't want to have, I don't want to open it up public because we don't want to have anybody outside changing it. The permissions are fairly granular. Okay, so that's the bulk. I think that's the overview of what's in the project. There's a couple ways that you can start now is just to open up these data sets and just take a look at them and see what you can do with descriptive statistics. The main ones being the UNCTAD data set. There's a variety of ways to get at these. If you go into our data library and you click through, the resources section will get you a link to a CSV file. It's always going to be a CSV file. Even if it's geographic, it'll be a CSV file. If you go down into the references, where's my references? I don't have references on this one. References will get you links to the original file, but you can click on these and you can actually just copy these and load them right into, Jupyter or Pandas. You can load these URLs. If you scroll down to packages, you click on that again. I clicked on packages right here. You'll get a collection of these are metadata URLs, and I'm using a system I built called MetaTab. That is meant for packaging data. This CSV file right here is actually the metadata that tells you where everything is. You can use that through Metapack. If you pip install Metapack, you'll be able to open the package directly and then pull out geographic data frames for things. And that's what I'll show you in a little bit. But you can also just read the CSV file directly. You can literally just copy this, just cut and paste that into Jupyter, and you will get this version 1.1.1 of the SEZ data set. You could go to the original one. You should go to this one because it's versioned. The original ones, you have no idea when they change it if you're changing your analysis. If you use this one, it's fixed and it's versioned. That's part of the reason for the system to exist. All right, any questions on that? All right, so just a poll, folks, is everyone, when I've interviewed folks, it sounds like everyone's pretty comfortable with the Python tool set, Python, Jupyter, Pandas.
I can say that everyone in my group, most of us are like recent graduates, so we are familiar with Jupyter Notebooks, Python, GitHub. I mean, that's kind of, you have to
Awesome.
to take those higher level courses to graduate. So we're familiar with all of that stuff. Some of the stuff that you do specifically in this project will be new for us and challenging, and we'll have to learn some new things. But in general, yeah, we have the fundamentals down for sure.
Excellent. All right, so let me close out some of this stuff, and then we're gonna go back to the wiki. I'm gonna walk you to our links. If you go into the wiki, wiki meeting notes, and then the kickoff meeting, you're going to get 2 notebooks. These are the notebooks that I've been working on recently to use those data sets and do some basic analysis. And I'll show you what the basic idea for the research is. So, well, actually, let me back up. If you go back into the wiki and you look at the nighttime light study ideas, these are some of my ideas on how to do the analysis. Again, it's not set in stone, but it's vaguely reasonable. If you want to add to this, you can edit this and add some stuff onto it for other ideas. But this is basically what I've been thinking about on how to go through the analysis. The way I've done that is in these 2 notebooks. These will be in our GitHub project, and this should be an open project. So if you go and you can clone this one, if you do clone it, if you're familiar with Jupyter and GitHub, you know they don't like each other very much. We could set up some systems for making Jupyter notebooks mergeable, but they're not mergeable. So if you open a Jupyter notebook and do anything to it, you're going to change it because your system will eventually save it. So what we do is within the notebooks directory, if you want to add notebooks to this repository, the first thing I have to do is add you to it. I haven't done that yet, but I will add everybody who's added a GitHub account to Redmine. I'll add you to this. But I'll just make a directory with your name on it. And if you want to work with somebody else's notebook, just copy it over to yours, and then we don't have to worry about merging. That will save a lot of headaches when you're trying to figure out how to deal with GitHub merges in a JSON file. Anyway, my notebooks are showing you the two processes that we're going to go through. So let me go back and so we're back at the kickoff meeting. We're going to look at creating patches. All right, any questions so far? All right, so
this is Dwayne. I do have a question. I couldn't get to that one page where you defined the Python import of the metapack and the import of that CSV file. Could you paste that link directly in the chat so I can just find it? Because I don't have metapack installed and I was a little confused on that.
Yeah, I'll show you to get there. Can you get to the wiki?
Yeah, I made it there.
Yeah, go into data sets and the first link right here. That's a search that has SCZ will be the tag that all the data sets I publish to our site will be. And well, it's any of them, but the special economic zones is the one I was looking at. And then it's under packages, which will take you down to it just scrolls down to the bottom. And that's right there. This one right here or this one right here. Is that what you're looking at?
I've only got one monitor on this laptop, so I'm almost there. Okay,
Yep.
so resources. I'm on the special economic zone. And where was the packages thing? Oh, okay, I found it. Okay, got it.
All right, excellent. Yeah, we'll show you to do this with this will be in the Jupyter notebooks as well. So let's see. If you want to set up, well, let's go back a bit. If you check out this project, I've mostly kept the Conda environment up to date. So if you go into here for requirements and you're running Anaconda, which if you're doing geographic analysis, you probably want to be doing Anaconda. You can set up all the geographic stuff on anything, but it takes a lot of work. With Max, you got to set up some external packages, or you got to use Brew in order to get the geographic data, the geographic libraries. And Conda does a pretty good job of it. Conda is terrible after you get it set up and then you have to pip install stuff. It's a disaster. And so usually I set up these Conda environments and then it's pip from there on because I can't deal with Condas taking 2 hours to figure out if the environment is solved. You probably want this one right here. The Conda environment is a big one, but most of it is going to be dependencies that are reasonable. And I think it has all the metapack stuff in it too. Where is it? Oh, shoot. I might have to update this one. Yeah, let me get to that and try that out later. Use this one. Let me take a look. Yeah, let me. If you have troubles with that, let me go and try it. But you should just be able to do pip install metapack, and actually you should be able to pip install any of these things that are missing. I think Bodo and H5PY are missing from it currently, so you might have to do a little bit of work on this one. but I'll get the cond environment fixed so this will work correctly this week. So this is how you open a package in Metapack, and you're actually loading in a metadata file that tells you where all the URLs are, and what it gives you is if you print it out, you'll get the documentation, links to documentation, links to, the where the data sets got downloaded from, this is the web page it came from, and then this right here is the actual resource. You pull that in with a resource.geoframe. This will create a GeoPandas data frame, so you can do geographic manipulations on it. Are you guys familiar with GeoPandas?
No.
Oh, you gotta learn GeoPandas. GeoPandas,
yeah,
is awesome.
that's on the list now.
GeoPandas is awesome. It is a really, really fantastic library. So what we're doing, let me open this up a little bit. What we're doing here is I'm going to create a geoframe, which is a geographic data frame, but one of the columns is going to be geographic objects, and you can do a bunch of stuff on that column. It's called geometry. In this case, what I'm doing is I'm converting it to a different reference frame. It'll originally come in as latitude and longitude, and you can't do area calculations on latitude and longitude because the stuff towards the poles is smaller than this stuff at the equator. So I'm converting it to a world Mercator, which is in meters, not latitude and longitude, and then I can create a buffer. That creates a ring. It actually creates a circle area. It's 2,000 kilometers, 20 kilometers radius. And then I apply that back to the data set. That gives me a way of linking into, oh wait, where did this go? Oh shoot, I got these backwards. Let me go back one. I want to make circular patches. That's the first one I want. Let's see, here we go. So we're going to create, we're going to take these SEZs. These are points. They're listed as points. And if you turn them into circles, you can pluck out a little patch that is going to be the area around those SEZs. So let me change views here so I can show you a different view. All right, so we're going to make the circular patch. So if we go and look at this data set, this geographic data set, we can plot it. We can just do SEZ.plot, and we're going to need to expand these out a little bit. So I'm going to go and make these buffers a little bigger. Let's make these 200K or 100K. And then plot it. All right, so we got a little point so you can kind of see the world there. If we made these 1 million, we get some nice circles there. So those were all the SEZs are. We've made them into these circles so that we can overlay this with the raster and pull out patches around the SEZs and then analyze how much light is in those patches, right? Mm. Now, the library we're using is called raster.io. You can go, look up raster.io for a description of it. Raster.io is a fantastic library for working with geo-referenced TIFF files. TIFF is a image format, just like JPEG or GIF, except it's lossless. There's a compression to it, but it doesn't lose any data. It also has a sophisticated metadata feature in it. So it was chosen to represent geographic data, So if you have an image of the world and you want to describe how that image would lay over a map, you do it in GeoTIFFs. And raster.io is the library for working with those. What we're going to do here is we're going to grab a reference. And this is unfortunately a complicated way of doing it that only I know about, but it gets you a reference from the package of, we created a package for all these nighttime lights rasters. And we're going to go through each one of them and pluck out the one for a year. And then this line right here, which you can see in the raster.io documentation, I included the documentation link. What this is going to do is open up raster.io. It's going to take that shape that we've selected, and it's going to cut out that part of the raster. So, for this, I don't know where this is, somewhere in the Pacific. This one right here, it's going to just take that area and produce a numpy array that has the night light data for just that section. And then what I'm doing here is creating a parallel task running on 10 processors to do all those extractions, because it'll take a couple hours if you didn't do it parallel. Then I upload that file so that you don't have to all this work. You can just download the file. We're going to upload it as an HDF5 file. And then this is what you get. So that process, you shouldn't have to replicate that. You should kind of know what it's doing, but I'm going to show you how to download and get data out of that HDF5 file. This is what it looks like. There's about 1,100 of these images. Each one of them is a section of the world for 1 year. I didn't plot any of that on this picture, but that's what they all look like. You can see the ones that are at moderate latitudes, they're 33 north or so, they're going to be roughly circles. As they get farther north, like this one, they end up being kind of squat. This is because I converted these back to latitude and longitude. They're actually circles, but the way that the pixels are laid out, that's how they're structured. So regardless of what size they are, you have to treat them as being essentially the same size. We have to do some adjustments for that. But what we can do from there is you line up all the rasters for one SEZ over all the years, and you can start to plot out how the lights changed, either by averaging them or adding them up. If you want to use a square, you can put a square shape in here and get a square out. You can go plug in the administrative boundaries that you saw earlier and get the shape of the administrative boundary. In fact, if you go look at the blog post I did, let's go data.org. That is not how you spell San Diego data. So if you look at this last blog post, you will see these are not circles. These are the second level administrative regions of South Korea. And I think this is for 2018. So some of these are real small. You can see how pixelated this one is. Some of them are pretty big. But same idea. We just use different shapes. So that's how you make the patches. If you want to select your own shapes, this is the process you'd go through. If you want to use the patches, what you do is you go download this file right here. Now this section of the notebook is downloading this file, but you can use this file. This is an H5 file, HDF5. I'm going to put that in the chat. I always lose my chat. Participants. Oh no, it's off the screen. So there's the HDF. Has anybody worked with HDF5? Anybody familiar with it? No, nobody. Right. So HDF5 is kind of like a zip file. It's a similar idea to a zip file, roughly. It's structured, hierarchical, it's like a file system within a file, but it's designed around storing tabular data. It can do it extremely efficiently and with compression. I don't recall that I actually used compression on this one. The compression's awesome. It does a fantastic job. And it gives you, and the Python system for accessing HDF5 is really nice. So here's where I'm loading it right here. I construct a key, the name of, I actually go through and get all the keys. Let's go print out some of those keys.
I remember this now. Me and Aaliyah actually worked on a project together where we had to do this. Yeah, it's all coming back to me now. It was such a pain before when we didn't realize that you could do this.
Yeah, the HDF5 is it's old. It's really old, and well, HDF is old. HDF5 is maybe a decade old. I think the other versions, but it's been around for a long time. So in this bit of code, this is kind of complicated, but what I'm doing is I'm downloading it using request package, writing it to the local directory. It doesn't have a good way of just like listing out all the keys. You actually have to do a visitor pattern and walk through stuff. So this is an idiom for doing that, but it gets you back all the keys. And these are some of the keys. So when you open up the file, when I do this, when I open up the patches.h5 file as a file, you literally have a it's a dictionary interface. So you can see right here, K is a key, and I do FK to index to get a reference to the raster there. And then this idiom right here, this is just slice notation saying from the beginning to the end. It just copies the whole thing off of the data set. You can copy slices too if you want, because HDF is meant for really, really big files. I've got a bunch of them that are like 25 gigs, and you don't load in the whole file, you load in a slice of it. But this idiom here pulls up one of these keys and then takes the whole raster and then prints it out. So this R right here is just a plain old numpy. Let's go run that. Well, it's mostly a plain old numpy. You have to read the raster IO documentation for this, but if you look at the shape of this, it's kind of weird. It has, not that. It's got one empty dimension at the start, and then it's a 42 by 48 image. So if you try to show it with matplotlib, it won't come out quite right, but you can use the show function from raster IO, and then it'll show it. It'll print it out and show it as an image. There you go. Any questions on that so far? Look at all those pixels. So this one, what we're going to do next is, and I know this is super complicated. Once we start getting tickets, I'm happy to work with everybody individually on kind of going through the code in detail and figuring out what it is. There's a lot of idioms here which are a bit advanced, and I apologize for that. I tried to simplify it so that it's easier to get through, but if you're having trouble with it, don't hesitate to call me. And you can literally just, like, phone calls are great. I will answer your phone call. What we're going to do here is collect, I go through all the keys. Remember, the key has these components. It's got the unique ID of the SEZ and the year. That data is in the key. And so I'm going to make a data set out of this. But I'm going to take each of these rasters and I'm going to sum all the pixel values up. And then my SEZ data set has a geographic area, which I previously computed from up here. I computed the geographic area before I converted it back to latitude and longitude. That's in meters square. So I can divide those out. I can take the sum of all the pixels, and then I can divide the geographic area in there and get an average light intensity. So that's what we're doing here to produce the mean light value. So let's, oops. I might have to rerun this thing. Oh, I gotta run this, then this, then this, then this. I forgot how long this takes. Sorry. Oh, there we go. So then what I end up with after dividing by this geographic area is we get a mean light intensity. I've also gone through this one right here. I'm doing the unit norm. So the largest value is 1, the smallest value is 0. It's just a little easier to deal with than all these zeros. And then after that, basically what we do after that is this line right here is NumPy's polynomial fit of order 1, which is a line. So we're fitting the line to the section of this op year is the year that the SEZ was started. And so BF is the before times, before the operational year, and AF is all the light intensities after the operational year, and we just compute the slopes. So what you end up with is a slope, a line with some slope before the SEZ started, and a line with some slope afterwards. Those slopes are growth rates, more or less. And that gets us a way of looking at the distribution of effects. So if you remember what Jeff said, he said that most of the SEZs, they're not actually doing anything. Well, here you go. This whole thing, all this stuff over here, these are the over on 0. These are the ones that didn't work. So this is a distribution of the ratio of the slope after the SEZ started to before the SEZ started. I made it on a symmetric log axis so that it's a little easier to see. So you can see that it's a logarithmic x-axis, but it goes logarithmic in both directions. And you can see that there's quite a lot of these SEZs that are just doing nothing. There's a lot that are doing something though. And so what we're going to try to do is figure out what puts an SEZ on either side of this line. That's the crux of the kind of analysis that we're likely to do. Once you've got this kind of measure of light intensity changes on either side of the boundary, then let's take a look at what's in this SEZ file. Well, that's not going to work. Let's do columns. Well, actually, we can also do this. If we go and take this resource, see this right here, if we just print this resource out from the package, it'll get you the data dictionary. I have added no descriptions to this, but it'll give you all the header names. And you can see what they've created in this data set for these SEZs. Not only the positions, but what country it's in, the legal, there's various text strings for legal framework, when it's, how outside entities are involved with it, who the developers are working with, corporate tax rates. I mean, it's an enormous amount of data. I don't know exactly what all these things mean, and the source for this doesn't actually explain it very well. So if you go to the dataset webpage on here, you can also get to this from from the data library. So if you go into, let's go back. I'll show you one more time how to get there. Let's go to Redmine, projects, SEZ analysis, wiki, and then into data sets. This URL right here is the search for all our data sets. Or you can probably just go up you just probably just go to the data library and type in SEZ. Yeah, that works too. So if you go into these packages, you can get all the links to wherever data set's coming from. And let's go take a look at what it's the original source data dictionary is, which it's nothing. They don't really have a lot of description of what's in this data set. You might find, well, this is like a geographic thing. They don't provide much information, so we're going to have to guess at some of this stuff. Yeah, I haven't found a good data dictionary upstream. But like I said, there is an awful lot in there, and these are the features that, to the extent we can understand them, we should be doing some classification to figure out what among these things is important for determining whether or not you're one of the SEZs that are on the below 0 or above 0. That's the gist of it.
I'm just wondering, if we wanted to find those ones that were doing well, how could we now from this find out which SEZs those were, or where they were located?
Well, in this set here, so we're looking at the slopes data set is one I just plotted. And so we're going to say slopes smaller than 0. Oops. Slopes, I'm sorry, that's not right. Slopes, slope diff smaller than 0. That's the, what did I do there? I did slopes diff was actually the relative difference. So that's correct. All right, so we can find the ones that are below 0. You can get the unique IDs. Right, there's the unique IDs. Let's set that in a set, and then if you go back into SEZ, SEZ dot. So these are all the ones that didn't do well. Let's do a head on this. And there should be a country code here. Let's do country. Let's see. Let's do value counts. Here. Oh, Turkey. Oh boy, that's almost all of Turkey right there. And let's do one that's not in. Oh, yeah, we'll do not in here, which will be above 0. So it looks like let's do a head on this to get the top ones. So the first one here is the countries that performed well, and mostly had SEZs that were performing. They were doing worse over time, and these are the countries that are mostly doing better. That's really stark. That's like ridiculously stark.
Yeah.
I'm serious. I was expecting these to be most of the same list, and it's just Korea that's on one side or the other. So there's definitely something there, that there's some countries that are not doing this right.
Yeah.
It could also be false reporting.
Yeah, well, there's probably a huge number of biases in the data set because they only have 10% of the records. So it could be the countries. I mean, a lot of these countries, like Turkey's economic data, who knows? Like, you have no idea. Did they actually, and what are their policies? What are their policies really? I don't know. Well, so remember that the metric here for China, I wouldn't trust much if China's publishing their their economic data. But remember that this is coming from photographs from space, so they're not dorking with those numbers. But whether or not that's real economic growth or not, or if they just there's lots of ways that a country can produce lights and things that look pretty. So we don't know about that, right? But if we take the lights as being an honest signal of economic growth, then we definitely have some variation here that we can work with.
Doesn't China have a number of ghost cities?
There are a bunch of those. I've read about those. Yeah, I don't know if they show up as being well lit. They could. I mean, maybe they've got a bunch of ghost coal-fired power plants that they're powering their ghost cities with. Who knows?
Well, I was actually from China, and they're like 2 SEZs from my city. Well, I think usually they're just allowing Western companies to do businesses without increasing taxation and stuff.
Yeah, honestly, for China, I would take these as an honest signal of economic growth. I think I seriously doubt that that these results are the result of government playing around with the data.
Just a side note, I'm sorry for cutting you off. I think like an SEZ in a country that's already like growing rapidly is gonna have a larger slope than countries that are not developing as rapidly as other countries.
That's a really good observation, and that's one that I'd like you all to have a look at. Is to get some assessment from the areas that aren't in SEZs as to what the baseline growth is. So, but on the other hand, the analysis process I'm using here, if you go back up and kind of look at what I'm doing, this is so this slope function is being run for every group of unique ID. So I'm taking all the years from one country or from one site, and then I'm going to do the log of the night lights. Not any particularly good reason other than economic growth. You usually want to log because it's exponential. And then resetting the year. Not that matters either. And then we're just doing a line fit through those, right? And that fit is going to happen for the before period and the after period relative to when the SEZ started. Now, those SEZs, they all start in different times. So if you've got a variety of SEZs that are coming in random times, that's something we should check, is how random are the operational years of the SEZs? Do they spread across a reasonable amount of time? Then you're comparing the before to the after is relatively random with respect to the whole country, and you should factor out those differences in growth, because then you're comparing the before to the after. It's not is the after very large? It's what's the after growth compared to the beginning growth. So you're looking for a change in slope. So that should take care of some of it. But I think your comment is correct, is that you probably should have a look at what would it mean to incorporate the economic growth of the whole country as
right.
As
I think about SEZs that started during the COVID pandemic, it's like, okay, that's a bad timing.
Yeah, so there's a couple ideas that I had there. One of them was, and I'll put these in as tickets. I'd like to have somebody do this circular patches process, but instead of creating circular patches, so if you remember this buffer right here is how you make the circular area. And then when you do this process of loading in the raster IO mask mask, this is actually loading in. Source here is actually the file name of the raster, and shapes are these geographic shapes that you're gonna load in. Do that with U.S. counties, or you do it with the BLS local area GDP statistics. I remember how to find this. So if we do this, if we go and look at local area gross domestic product, I think these are actually metros. It's not hard to figure out. I think they're metropolitans or counties. Is that we can go and look at the United States and get an estimate for what does a certain amount of light growth mean in terms of a certain amount of gross domestic product increase. You can actually get a rough handle on that. And that would be good for calibrating what's happening elsewhere. Is how much does a certain amount of change in lights mean to a change in dollars? Oops. But that's another task that somebody might want to take on. Let me ask. So I'd like to get folks kind of started on working with either just get introduced to working with these data sets and being able to do the processes that I had, being able to write your own code for that. Do you guys feel comfortable with the code that I've just shown, or do we need to go kind of work through some of the details? How familiar are you with what I've presented?
For me, some of this stuff is new, but I think that I understand what you're saying when you walk through it, and I just think I need to play around with it a little bit, but I think I get it mostly.
Okay. Well, you might want to give me well, if you're comfortable with fixing import errors, you will probably run into a few. You should be able to download or to clone the notebooks or clone the repository. Set up your Conda environment. You guys use Conda? You familiar with Anaconda? And
yeah, how do you set up Conda environment? I have a question.
Well, let's go back to let me go to Redmine. So I'm going to try this out again. I haven't set up a fresh environment lately, so I probably added a couple things I need to stick in there, but I'll go fix that. But if you go into the wiki and actually, you know what? You go into the overview of the project. This first overview will have a bunch of links to things. The file share is a Google directory. You can drop files on if you want. This is a home page. It's a page I haven't set up yet, so don't worry about that. We've got a Slack channel, but the GitHub link will take you into GitHub, obviously. And in the requirements directory, you will find real short instructions on setting up Anaconda. So just go to, search for Python Anaconda, install a recent version of Anaconda. This will create an environment for you called, oh shoot, it's the wrong name. I need to change that name. Let me go see what that. I'll do that. Let me send out some email when I fix some of these things. This one's actually called SEZ. So this instruction here, I'm running two projects right now, and they're both kind of sharing the same environment. So.
Oh, I see. So just taking the YAML file.
Yeah. So that YAML file describes where'd it go? This YAML file describes all of the packages. It'll have these are all packages that are part of Anaconda, which it'll install very quickly. And then after that are all the packages. There's a lot of them. These are all the pip files that it will install afterwards. And so when you're done, you should have a functional environment. But like I said, there's a few things that are broken with it. So let me fix that tonight, and then I'll email out I'll send out a news item that it's ready to go. But if you're okay with, like I said, if you're okay with doing some pip installs for stuff that doesn't exist because it'll throw an import error, then you can go ahead and try this. This will get you started with most of it.
Okay, sweet. Thanks, because I was having some import error with the meta pack.
I know there's a few that I'm missing, so I need to go try those out again. Let's see. Other comments or questions? Things that Taylor, how do you how does your team want to work on this? I mean, I'm pretty flexible in how things actually go. So, do you have any preferences on how we do things?
I was really wanting to sort of have another meeting with everybody because it's been sort of shifting around with who was going to join the group and who wasn't. And but once we finally get that solidified, I really like to talk with everybody about kind of committing to just at least meeting regularly and working together on things, even if it's only just for like an hour or two. And then doing like our own work separately throughout the week, but definitely spending like a couple hours, maybe more each week working on the project together. That way we're all on the same page together. But so I'd like to work on it as a group together. That way we can help each other out. But then also just be able to work on it in our own free time. And then and meet deadlines, like we make a deadline and we say, this is what we want to do. We want it done by Monday or whatever day it is. And then, so that's kind of like the work schedule I was looking for. I don't know how that works with you or what you were expecting.
I think it's awesome.
Okay, cool.
Yeah. So the client hasn't really set any parameters. They're growing, and so they're not and they don't really have the resources yet to tackle all the things they want to tackle. So this is a benefit to them. They're quite happy to get what they can get. I think that we should have some structure to really crank things out, because this is a really fascinating project, and it does have. I like it because it does have some big impacts in the world. If you kind of read through the what's worked and what hasn't in the field, there's and you can see this in the graph, right? That graph I showed. There's a bunch of failures here. Where did it go? There's a lot of things that they countries spent billions on these cities and it just didn't work. There's a good article that I'll post about the smart city efforts in Africa that were just they built a bunch of shells of buildings and got nowhere. And so being able to get a solid understanding of how that works and how to create a Dubai or a Hong Kong instead of a ghost city has a major economic value to people. So I do think there's a lot of social import to this. And so it's worthwhile to do some good work on this and help move things along.
I think it would be good if I could schedule just multiple meetings through the week, just like for us to work on projects together. And then maybe, a once a week, we could schedule a meeting with you just to sort of or just have like kind of a scheduled time to where maybe not everybody comes, but people who have the time to come can come. And if we have questions about what we're doing, or if we're going in a certain direction, we want your advice on it, then we just have that set time that is sort of like once a week. We just know that that's the time to ask questions, to check in with you, and then set times for just me and my team to be able to be together.
Yeah, that'd be perfect. And I think a good way to do that is the meeting starts with you get a few folks that have done something that they want to talk about. I think that's a real benefit to everybody. You should get on and whatever you've done, just kind of do a talk to it. Mm-hmm. And share ideas with that analysis and how you did it. And then the rest of it is to work through ideas. We should spend a little time on talking about the tasks and what the ideas are. So that's what we'll be putting into the management site is tickets for analysis to do. And then multiple people, one or more, can work on each of those tasks, and we can help people get through those things and produce some outputs. And then they present that to the group.
That's good.
How will we be managing our code? Will we be pushing to individual branches on GitHub? Will we be using our own GitHub accounts?
You can do it in a variety of welcome, Aaron. Paths. The only thing that's really important is that if you work with other people's notebooks in the main branch of the main repository, you don't let them get saved. that's the big thing. But if you want to
use my branch.
What's that?
I use my branch.
You can use your branch.
I've made those mistakes too many times.
Yeah, no, you can use your own branch, or you can just focus on using your own directory in the main branch.
Okay.
You know, it's not that much of a problem. It's just that every now and then you get. The other thing that's really important if you're using GitHub is be really careful about committing big files. You know, if you go, like, if you look at my the examples I was giving, I have a pickle file and an H5 file, and they're big. I have those. This thing, CSV, H5, and PKL are get ignored. In several of the directories, but not in all of them, because some of them have to have CSV files. So you do want to be really careful, because I don't know if you've had to remove big files from a repository. Oh, it's a pain. It's a real pain. Even with the really handy programs for removing big files from repositories, it's a major pain. So you will not be popular if you check in a gigabyte file. Actually, luckily you can't check in a gigabyte file, but without special things. But even 10 megabytes will make you unpopular. So that's the only big deal.
Gotcha.
Any other questions? If not, I think Teo and I can work on whatever the next steps are. Like I said, I'll make sure that the environment is clean. So you should be able to, and I'll send out an email with the instructions. Use the README file in the requirements directory to create an environment, and then you should be able to run those notebooks and produce them. One of them, if you do create the circular patches, it takes 20 minutes, and it'll fail when you try to upload them because you don't have access to that file. But everything else should work for you.
Sounds good. Is this like a good time for meeting again in the future? Is like the 7 to 9 work for everybody to maybe meet with you again next week?
Yeah. I think next week should be good. I'm got a vacation, 2-week vacation coming up, but that's
nice.
in late after the 23rd, so we'll be available before then.
Okay. Great. So for now, do we just want to sort of like play around with what you've shown us, and then make sure that we understand it and don't have any questions before we dive in?
It'd be worthwhile to try your hand at extracting rasters and thinking about how to assess, how to produce a metric. If you pull out a patch from the raster file, how do you create a metric of how much economic activity is in that patch? Do you sum everything up? Do you average it? Do you do logs or not? That's one thing. The other one that would be really valuable for early exploration is just some descriptive statistics on the SCZ file. It's got 80 columns in it, and I've worked with a variety of feature analysis packages like Missing Info and others, but I haven't done that with this one. So I don't really know what the quality of those features are. I'm absolutely positive that there are some serious selection biases in this file. I don't know what they are. I have no idea, but I'm pretty sure that if there's only 10% of the SCZs in that file, it is not a random 10%. So that's going to have a significant impact on the analysis. And if we're just doing interesting results, doesn't matter. But if you get to a point where you've got something usable or publishable, that is really going to be important, that we have some sense that there's a randomization of what that 10% is. And I haven't thought about that enough to have any ideas on it. But if there's a way to get another data set that's with less information, but maybe has all the SCZs, or some other way to estimate where other SCZs are, I don't know. We do need to characterize the quality of the data, because, as you know, if you have data, it's probably not good. There's a problem with it somewhere.
All right, so that sounds like a good plan. We'll just try out what you have here and maybe just do some EDA and just see if we can find anything interesting to sort of play around with it for maybe next week. Does that sound like enough?
Sounds perfect.
Okay.
I'll let you organize those things. I'll have occasional meetings, but mostly that I'll organize, but mostly they'll be for, working with Jeff or a larger group of people on presenting results. But as far as the working meetings, I'll let you do those.
Okay. Sounds good.
All right, fantastic. Well, thank you so much for getting involved with this. It's a pleasure to meet you. I look forward to working with you.
Yeah, super excited about it. This is Aaron, by the way. He just joined in. He's also part of Cognos here.
Yeah, I had a midterm, so I'm very thankful that I came for the last 5 minutes.
I'll fill you in later.
Yeah,
Hopefully
I hope so. They don't tell me yet, but hopefully.
So this is recorded. It's probably going to take a while to upload since it's so long, but
yeah, we'll see.
All right. Well, great.
All right. Thank you very much. We'll talk to y'all later. Bye.
Thank you.
Right.
See you. Bye.
Bye.
Thank you.